A problem of this type is usually asked under the chemical calculations, but we can also consider this under qualitative analysis because this involves some reactions of metallic salts. Now, a mixture is given. This mixture contains two metallic carbonates, namely calcium carbonate and magnesium carbonate. The weight of the mixture is given as 1 gram. That is weight of CaCO3 plus that of MgCO3 is equal to 1 gram. All right. Now this mixture is heated. It says the mixture is heated till there is no loss of weight. All right. After heating this mixture, you get a residue. This residue weighs 0.5 gram. What is the percentage of CaCO3? Now here you should remember the reaction of a carbonate. A carbonate like CaCO3 or MgCO3 on heating will give these two products. CaCO3 on heating gives CaO and CO2. Please remember, in working problems of this type, always you should give a balanced equation based on which alone you should work out these problems. It is a balanced equation. CaCO3 on heating gives CaO and CO2. A similar reaction takes place in the case of magnesium carbonate, MgO plus CO2. And you are aware of the fact. The residue will be the oxides of these two metals because the other product is a gas, it escapes. So, the residue after heating contains a mixture of calcium oxide and MgO. Now, usually whenever you take the weights of materials, this point is usually mentioned, heated till there is no loss of weight. That means the reaction takes place completely. That is what is meant by till there is no loss of weight. The weight of the final residue is given. That is CaO plus MgO is equal to 0.5. Now find the percentage composition of CaCO3. If you know this, the remaining percentage will be that of magnesium carbonate. Now I assume the weight of calcium carbonate to be X. It is given calcium carbonate plus magnesium carbonate weight equal to 1 gram. So I assume of this 1 gram, X gram is the weight of calcium carbonate where X is less than 1. It is obvious. Naturally, what will be the weight of magnesium carbonate? 1 minus X will be the weight of magnesium carbonate. Do you understand? Now, CaCO3 molecular mass is 100. Molecular mass of CaO is 56. So, it is clear from this equation, if I take 100 grams of calcium carbonate, it will give a residue of 56 grams. Of course, the remaining will be the weight of carbon dioxide which has escaped. So, 100 grams of calcium carbonate on heating gives 56 grams of calcium oxide. Now, this I get from this balanced equation and the corresponding molecular masses. But I have assumed the weight of calcium carbonate to be X. So, if 100 grams of calcium carbonate give 56 grams of CaO, X grams of calcium carbonate will give X into 56 by 100 gram of calcium oxide. Similarly, you can work out 84 is the molecular mass of magnesium carbonate. From this balanced equation, again it is very clear, 84 grams of magnesium carbonate will give 40 grams of MgO. But I have assumed 1 minus X to be the weight of magnesium carbonate. So 1 minus X gram of magnesium carbonate will give 1 minus X within brackets into 40 by 84 grams of MgO. So I have obtained the weights of two residues. Weight of CaO 56X by 100. Weight of magnesium oxide 40 into 1 minus X by 84. But in the problem it is given the final weight of the residue, that means weight of calcium oxide plus magnesium oxide is 0.5. That means 56X by 100 plus 40 into 1 minus X by 84 is equal to 0.5. You can solve this and get a value for X. This X works out to be 0.284 grams. 0.284 grams. Of course, roughly we can say X may be correct. In this sense, it is less than 1 because the total weight is 1. Naturally, X should be less than 1. Or if you convert this into percentage, multiply this by 100. This will work out to 28.4%. But in the problem it is given, it is a mixture of two carbonates. So if calcium carbonate percentage is 28.4, 100 minus this, around 71.6 will be the percentage of magnesium carbonate. It is quite obvious, since the total weight of these two carbonates is 1. This 1 gram on solving we find contains 0.284 grams of calcium carbonate. Or if you convert this into percentage, multiply this by 100 because 1 gram of the mixture contains so many grams of calcium carbonate. So if you take 100 grams of the mixture, you multiply this by 100, which will work out to 28.4 percentage of calcium carbonate, the remaining being the percentage of magnesium carbonate. So whenever you take problems like this, give balanced equation, work out correctly the molecular masses from which it is possible for us in simple terms the percentage, etc. So problems like this, these are based on chemical calculations we usually say, but this is based on the reaction of the corresponding carbonates. Do you follow?